here is today's session about processing sensitive unstructured data with sovereign AI. So this is a problem, an extraction problem that many of you might have run into firsthand. So especially when you want to extract data from sensitive documents, many times the compliance teams come in the way and give you a strict no. And honestly, they do have a point because sending sensitive data to a hosted AI API can create real risks like data residency violations, third-party exposure, or regulatory penalties. So today's session is all about how you tackle this challenge. We are joined by Shuveb, Unstract co-founder and CEO, and he's going to be taking us through what sovereign AI is all about and how it applies to document extraction. In this session, we'll also cover a detailed walkthrough of the architecture that makes this possible for document extraction, and specifically how Unstract and NVIDIA NIM work together to run the entire extraction pipeline, right from document intake to AI inference to structured output, all inside your own network. So with that, let me quickly introduce our speaker, Shuveb. So Shuveb is co-founder and CEO of Unstract, as I mentioned. In his previous role, he was VP Engineering of Platforms Engineering at Freshworks, a NASDAQ-listed global SaaS player. And in his career, he has co-founded multiple internet startups and has also had the fortune of working in startups that deal with petabytes of data and billions of requests every hour. So hi, Shuveb. Thank you so much for joining us.
Of course. Hi, everyone.
Yeah. And with that, before I hand over the session to Shuveb, I just wanted to quickly set the tone and actually introduce Unstruct to those of you that are completely new and joining us today. So Unstruct is an agentic AI document processing and extraction platform. If I had to talk about this, you could basically put the capabilities of the platform in three major segments. So firstly, once you upload your document, it would go through a text extraction phase where the platform deploys a text extractor to extract the raw text in a layout preserved format from your document. And once this context is available, it is then sent to the development phase where you can deploy LLMs to actually extract the data in the schema that you want. So here in the development phase is where all the prompt engineering happens. And with today's capabilities in the platform, you can also completely automate the extraction phase, from the schema generation to prompt generation to also validating the extracted output. So once you define the prompts and you get the output in the format that you want from the document, you can then deploy this particular project in any of the deployment options that we offer, depending on what suits your business best. So currently, natively, we have API deployments, ETL pipelines, task pipelines, and also human-in-the-loop deployments. But for certain advanced use cases, you can also go for MCP tools that are available for Unstract, as well as our very own text extractor tool, LLM Whisperer, or you can also go for N8N workflows. So this is basically how the overall workflow of the platform runs once you upload your document and all the way till you get the extracted output. And if I had to throw some numbers on where the platform stands today, currently we have 7.1K plus stars on GitHub, a 1,000 plus member Slack community, and we're also processing 10 million plus pages per month by paid users alone. So with that brief introduction, let me hand over the session to Shuveb, and he'll take us through what sovereign AI is all about. And in the demo segment, you'll also get to see Unstract hands-on and how it actually works in real time. So Shuveb, please take over. Thank you.
Thank you. Thank you, Marshall. So if you can go to the next slide, I just want to cover a few things. Or do you want me to present? I can also do that.
Yeah, I think that would be better, right?
Yeah, let me present. That's probably easier. Okay, there you go. Hope you're able to see my screen.
Yes, sure. That's visible.
Thank you. Yeah, so first let's cover what sovereign AI is and what the advantages really are, right? I mean, in essence, right? I mean, there's a lot of during the training of large language models, there can be a lot of restrictions put in by the developer of the model around various topics, the way it responds, the way it especially responds about political questions and moral, philosophical questions, and that could affect, your use case, right? So typically, people don't want to sometimes use, models from sometimes another country, especially if the use case is kind of sensitive. If you want to use it in healthcare, if you want to use it in legal, and then if you want to, let's say, use the model for military use cases, one has to be like super careful what the provenance of the model is. Otherwise, it can be, pretty disastrous, right? Examples of these sovereign AI models are in the US, you have GPT OSS, then you have the Nemotron models from NVIDIA, right? So these are all developed by US companies, which are pure US companies. And then from China, you have models from DeepSeek, you have Z.AI's GLM models, and then you have the Kimi models from Moonshot, right? Similarly, in the European Union, you have French-based the Mistral models, which are also pretty popular, especially in the EU. That's considered like a EU-centric model. And then in India, of course, you have the Sarvam open source models also, right? Of course, if you take a look at the models that I am talking about, I'm kind of partial towards the open source models. That is mainly because someone who is as sensitive to basically seek out a sovereign AI model might also kind of think whether, hey, they can run that model within their environment, right? So, if these are open weight models, it's better because then you can download the model, you can convert it to whatever hardware you have, and then you can run it, within your air-gapped environment or whether within your environment, even if it's a cloud environment, it doesn't really matter. You can run it as per your needs, and then your data doesn't have to leave your environment, right? Of course, there are people who are not at all on the cloud for various reasons, so they don't want to kind of give their data out pretty much anywhere, and they want to kind of run the whole infrastructure on their fully owned infrastructure, right? Like a data center that they own, right? So of course, when you talk about document extraction, there can be a lot of constraints when it comes to sovereignty that Mahashri spoke about. That, hey, pretty much right. I mean, you do have good models, but does your compliance team allow you to use those models, right? It can become a very quick problem for you, and we have seen customers where they really worry about, for instance, where the model is and what the compliance of those models are, and then, hey, what will they do with the data? Will they train the model with their data? Things like that, right? So we've seen that quite a bit, right? Of course, if you take regulated industries, there's all sorts of very personal data, PII data that goes through the system, and then they kind of really worry about it, right? So, of course, the solution to this is to make sure that you do two things. First is you make sure that the model that you use or you choose is basically a model that is compliant with your region. So I gave you some examples of US models and European models and Chinese models and Indian model. So you might want to choose something like that, right? And of course, you might also want to deploy it within your infrastructure so that your data does not leave your network, right? Of course, the you have to take care of how the document intake happens, and of course, Unstract can be used to self-host, and then provide a platform for document data extraction. And then, of course, the most popular way in which you can scalably and easily, do model inference is basically NVIDIA's NIM containers, right, which can basically which work really well with NVIDIA GPUs. I'll cover them, what the difference is in just a bit. Right. So NIM is basically NVIDIA inference module. So these are just software packages that allow you to have inference. They expose an API which Unstract can talk to, right? And then of course there's a lot of advantages in NIM, right? We'll see that in just a bit, right? Now, when it comes to Unstract, right, we do support a lot of different providers that you can connect to and then to create JSON data out of very complex unstructured documents. But I want to kind of bring your attention towards these three options, right? Using Olama is another very, very popular way to run custom models, right? And they also support NVIDIA GPUs and things like that. We do support Olama. Then there's another very interesting connector which is called OpenAI compatible. And it actually turns out that many providers who are not OpenAI, right? For instance, they actually follow OpenAI API compatibility, right? So think of it like this, right? So there was AWS and they had S3. But you have other providers also who have S3-like services, but they actually expose S3-like APIs. For instance, if you take Minayo or Minio, right, it exposes an S3-like API. So you can, in fact, use the same S3 clients to talk to Minio, right? Similarly, if you have, an OpenAI compatible SDK or a library, you can in fact talk to Olama. Of course, OpenAI compatible with OpenAI compatible like connector. You can connect to any service that has an OpenAI compatible API. And of course, NVIDIA NIM or NVIDIA Build, it allows you to connect to NVIDIA, inference service, which can then connect to the NVIDIA GPU, right? But then again, right, I mean, there's a lot of different ways when it comes to this is the software part and the connectivity part from Unstruct, right? But when it comes to hardware, there's a lot of options you have, and all of these options they are actually very different, right? I mean, although they look kind of similar, and you can do inference on top of lot of different hardware, the kind of flexibility and the capabilities of these hardware options vary very widely, right? For instance, you can get the latest GPUs from NVIDIA. These are essentially meant for gaming, but nothing is stopping you from running large language models on it. And then actually, a lot of people, they run local models for coding and other things, and like simple assistant models to kind of help them with their day to day, because they don't want their data to go out, or they don't want to pay and buy a subscription, right? So this is a very common option, but I'll compare and show you the differences. Then the kind of the mid-level, way to kind of run models is to get Apple hardware with a lot of memory. Unfortunately, there used to be like a Mac Studio with 512 GB RAM that's no longer available. It's like, I think because of RAM shortages, that model has been kind of pulled back. But then again, and I mean, you can even do distributed inference. You can run much larger models using multiple Macs. You can do all of that, right? But the standard way and the most, powerful way to actually run local models is using NVIDIA's hardware, like H100 and B200. So these are the kind of modules that are, it's not just about the hardware, although I have to tell you the hardware is excellent, and then there's no comparison with the rest of the options on the screen. But I have to tell you that the software ecosystem and the way that multiple hardware, multiple pieces of these hardware can actually be clustered together, it can be made to work together is unprecedented, right? So there's no comparison with the rest of the models, right? So let me walk you through some of the details and the capabilities, right? So here we are comparing a latest card from gaming card from NVIDIA, which is the RTX 5090 with the Mac Studio M3 Ultra, and then let's say the H100 80 GB XSM from NVIDIA, right? So if you look at the memory, this has 32 GB, GDDR7. On the Mac, you can have 96 GB. Like I told you, the 512 GB model is gone. And then this particular, I mean, although it looks like there's only 80 GB, you can kind of cluster these cards together. But then you will start seeing a lot of differences, right? Take a look at the bandwidth, the memory bandwidth, right? There's no comparison. So if you take the H100, right, it's like double to that of the bandwidth that the RTX 5090 has, and then of course the Mac has relatively less, right? And then this is teraflops, right? Trillion operations per second, right? So you can take a look at the kind of teraflops that this hardware can actually put out, right? And then of course there's power. Of course, the larger the module, the more the power. There's nothing surprising there. But then if you look at the cost, although this is MRP is much lesser on the street, these are like this probably $5,000. The Mac Studio is probably again around the same amount. But then typically when you go for H100 kind of hardware, you can't buy just one, right? Typically you buy eight, like a GPU node, which will actually come to close to like $500,000 for you, right? But I'll talk about the advantages, right? The advantages come when you want to scale out, right? So you have NVLink for the simple gaming cards. You can do Thunderbolt 5 based clustering for Macs. Right. Again, you will have some amount of decent bandwidth here, not a lot. But if you take a look at NVIDIA, these standards they are very, very mature. They are battle tested, and then they can work really, really well, right? Of course, the stack is you can use VLLM or OLAMA and Llama.cpp, all of that, and then H100s they have a lot of ecosystem, including NIM. They're pretty standard, right? Now, imagine what can fit into this kind of a hardware, right? So if you take these are all the BF16, FP8, Int8, 4-bit. These are all different ways of representing model weights, right? Of course the weights are open source, and then you have to convert the model weights into whatever format your cards can support, right? So if you take a look at this, these are all the kind of parameters up to which the system can support. Right, but then again, you can look at what a comfortable pick is for 5090. You can run a Qwen 332 billion parameter model. Mac, you can run GPT 4SS 120 with a particular quantization, right? And here you can run Qwen 332 billion and then Llama 70 billion, right? But that's not the main point here, right? So now I talk about what doesn't fit here, but there's an asterisk here, right? Now H100s, right? You get like typically when you buy, you have like eight cards in one module, and then you can actually scale it out, right? And NVIDIA, they have brilliant software ecosystem where you can actually do distributed inference. So you can cluster these machines together and run models that are much, much larger than what can fit into a single card, right? And you can achieve that using a Mac and also using, these consumer cards, but the software ecosystem is not very mature, right? Similarly, right, in if you look at like production quality, right, so you can look at what kind of tokens this can produce, and then you need to have a little bit of a headroom for other kind of housekeeping tasks. So you can kind of look at these numbers here, and this is very, very important, right? Just because you have hardware doesn't mean that you can pump in all sorts of requests there, right? Hardware also, they have a certain number of cores, and there's a limitation as to how many parallel requests you can run. Of course, on the cloud, you don't care. Your whole company is probably pumping out hundreds of requests in parallel. But when you run your own hardware, you have to be aware of what kind of parallelization or concurrency that particular hardware can actually handle, right? Right. Again, of course, if you have the proper NVIDIA stack, you can have hundreds of parallel threads in running. But then again, different hardware can give you different things. Otherwise, what you have to do is that your calls will get blocked, and as and when different requests get processed, then your request will, whatever out pending requests are there, they'll get scheduled on the hardware, right? You have to be very, very aware of this, right? A lot of customers don't understand that concurrency can be a big problem, and they generally go and buy hardware, and then they find out that, hey, there's a lot of demand in their organization which they are not able to meet, right? Similarly, right, you also have to worry about aggregate throughput, what kind of tokens per second you can do, because if the system is very slow, then the users might get really annoyed and they might stop using the system altogether, right? Of course, here, the small consumer grade GPUs are okay for to run one model, one team can run it, right? And then you can probably run bigger models on the Mac Studio kind of setup, but it's very low concurrency. But of course, actual multi-tenant serving you can do using NVIDIA's hardware, right? Now, when you look at NVIDIA's options, the H100 is slightly older chip, and then now you have the B200s, right? So although this card comes with 80 GB, the B200s come with actually 180 GB memory now, right? But if you look at the bandwidth, you can start seeing the difference, right? It's like more than double the bandwidth that B200 can do. And then you can look at what kind of teraflops this hardware is doing. It's kind of crazy, right? What it can do compared to the H100, right? And again, similarly, even in the interconnect that this is the interconnect used between the cards so that you can run distributed inference. The NVLink, NVLink here again is double what of that of the H100, right? Of course, it takes a little bit of more power, and famously, data centers consume a lot of power. We know all of that, right? So again, I'm continuing the comparison here. You can look at the cost. So this is between 30 to 40K. Again, it's pretty much the same. It's pretty much the same thing. But then, honestly speaking, there's so much demand that these cards usually go for up to $50,000 a pop, right? So it's pretty expensive, right? Right. Again, so like I said, hey, you're looking at something like $500,000 to set something up. Without this, I mean, it won't be usable, right? So otherwise, if you go for some other hardware, you'll be restricted in terms of what models you can run, what concurrency you can have, and then the quantization of the model. If it is too strict, let's say you boil it down to 4 bits, then the model loses intelligence in the process. So you have to be very careful there, right? Again, right? I mean, these are all very mature products, and then they're typically used for including training and inference and everything, right? I hope this gives you a really good idea about how you have to look at hardware and how things work there, and the practical kind of considerations you need to make when you deploy this kind of a system within your organization, right? Um, Now coming to how Unstruct you can use to kind of create structured data out of unstructured documents, right? So of course we have document intake here. We have ETL pipelines, APIs, and things like that, right? So and you send you send the documents to Unstruct. We will create structured data using pretty much anything, right? So I spoke to you about what kind of adapters we have, and then for NVIDIA NIM we do have an adapter. And then, in essence, right, Unstruct can basically use that, GPU, that large language model, to give you the structured data. Of course, I'm not sitting with the NVIDIA model here, but of course, these models are already, whatever models I gave you examples of, luckily, they're available on Open Router. And Open Router also, we do have a connector, right? Of course, once it's very easy for you to kind of, check out all sorts of models in Open Router, because there are quite literally hundreds of models available in Open Router. So it's a very good platform for you to experiment using, right? You'll be very surprised. There are relatively small, very cheap models that are very intelligent. Like, I'm a very big fan of the DeepSeek V4 Flash model, which is very like dirt cheap. At the same time, don't be fooled by the name. Usually, Flash models mean very small models, but this model is extremely smart, and I've been using it. I've been playing around with it with some projects, and even for very complex documents, it does a really, really fantastic job, right? So, of course, we'll be connecting today to Open Router, but nothing stops you from taking the same models which are available in Open Router, going to Hugging Face, downloading the weights, and then running it in your own infrastructure using one of the hardware options we discussed today, right? And there, depending on like how you are exposing that large language model using VLLM or Olama or NIM, we have connectors for all of those. You can connect Unstract to your own hardware or for testing to Open Router, and we can go from there, right? So let me switch over and show you a couple of examples that I have set up, right? Now, coming to this project, in this particular project, right, we have, this is a US credit card statement parser, and I have configured 3 different models. I have DeepSeek here, then I have, GLM 5.2, and I also have NVIDIA's Nemotron 3 Ultra, right? And in Unstruct, right, what you can do is that you can compare models side by side, right? The same extraction, the same prompt, you can compare side by side, right? And you can look at the output here, right? So in this particular, in this particular example, we have 3 different variants of the US credit card statements. So this is, of course, this is from Amex. We have one from Chase Mileage Plus, and you can see it loading in the background. Then we also have one from Bank of America, right? And so these are all statements which are completely arbitrary, right? They are meant to be read by humans, so they are very different from each other, right? And these are regular statements. There's nothing fancy about them. Just regular statements, right? And it has a list of spend items and all sorts of, all sorts of things. And in Unstruct, we have these prompt cells in which you give a prompt name and then you give the actual prompt. Of course, this is a toy prompt, and in any production prompt will usually be hundreds of lines long, right? And then we have coverage, which I'll show you. So this American Express is for this particular document, but we have three different documents, right? So you can look at coverage here. So for the different documents, what is the name of the issuer, which is getting pulled out, right? And between the different models, is there any difference and things like that? You can see all of that here, right? This helps you debug, right? Of course, there's also a type that is associated with every prompt cell. Here we have a text number, all sorts of things, and then we also have advanced options like agentic table extractor, which is designed to extract tables from complex documents, which runs a agentic pipeline to do that, right? Of course, you can also click on any extracted value, and then it will scroll to the right location and highlight the area from where the large language model is picking up this information from, right? Similarly for the name of the customer also, right? And then we have customer address, right, which is a JSON field this time, right? And you can again, you can click here and get the information from where it's pulling out. Even if it's multiple lines, we do highlight, right? Then you have payment information. Then you have the spend line items. Whenever it's very long, you can always expand and look at the extractions from the different large language models side by side, so that you can choose a good model, right? And you can also switch to combine output to see the whole JSON, right, for this particular document. Of course, we have output analyzer, which allows you to analyze, hey, for a particular variant, what does the JSON data look like, right? So you can kind of do that side by side view as well, right? Of course, whenever you're happy, you simply click on deploy as an API, and that's it. It just gets deployed as an API, and you can send new documents, new credit card statements over, and you will be able to get JSON data back, right? So as you can see here, these models are doing a fantastic job, right? They're able to kind of and the output is actually identical, right? So they're all doing a good job. Although Flash model is supposed to be really, really tiny, it's actually doing a pretty good job, right? Now, of course, this is a relatively clean document, right? So, but we can deal with very shabby, very complex documents. For instance, take a look at this handwritten form. There are three challenges here. One is that there's handwritten text, right? Second is there's hand-checked radio buttons and hand-checked checkboxes that we also need to interpret. And then the third challenge is that we have an off orientation scan, right? Now, if you take this particular document, especially if you take citizenship, right? If you look at the prompt, it's actually a very simple prompt, just a simple 4-line prompt, right? And if you look at it, all the large language models are actually able to figure out, hey, it's US citizen, right? I can even highlight it here, right? The reason why this works so well is because of how we translate this for the large language model, right? So if you take this particular citizenship area, if you switch from PDF view to raw view, you can see two things, right? How carefully we maintain column layout and how we convert the radio buttons into something that the large language models can easily understand, right? So because of these two things, it works really well. Also, you can take a look at, how this is the end of the page marker, how we have fixed the out of orientation, off orientation US driver's license, right? So this was how the license was, but then we fixed it and made it like this, right? So what happens in essence is that this document now becomes, if you switch to combine output, it becomes a clean, super clean JSON data like this, right? So we can do this again. Here we're using the same set of models, Flash, GLM 5.2, and Nemotron 3 Ultra. And you can see they're doing a fantastic job, right? They're able to understand, text that is kind of in a form really well. So if you this is the input that we're giving to the large language models. And as you can see, it's kind of we are maintaining the layout very carefully. But then, hey, unless the model is smart, it cannot figure all these things out, right? For instance, it's able to figure out that it's an individual applicant. It's able to figure out that this particular person is married based on the checkbox and things like that, because from this they are able to get it. So the model's actually pretty smart, right? And finally, I want to show you another document, which is a very common thing, right? So a lot of businesses, they deal with receipts and for reimbursements and things like that. So this is just a photo, very normal photo of a receipt. And even here, the models have done a good job. Again, I'm using exactly the same models. The prompts are actually very, very simple. Sometimes single line prompts, sometimes a little bit more detailed, but nothing fancy, right? These just very, very normal prompts. And then, of course, they show some individuality. I'm asking them to rate how healthy the food is. So Nemotron thinks it's very unhealthy, right, and things like that, right? So I think GLM 5.2 is a little forgiving, right? Again, this particular document is turned into raw text like this, very carefully preserving layout. And so, from this text, right, it's kind of difficult to figure out, hey, what the items are and things like that. But then if you look at the JSON data, it's very clear. The two items are here. One is 400 rupees, another one is 130 rupees. Jack the Ripper, which is the burger and the plain fries plus Coke, right? These are the items, the two items that are here, but they are on multiple lines, right? Although they are on four lines, they are only two items. Models have figured it out very easily, right? There you go. And if you look at the combined output, it's super clean, right? Like this. So yeah, so that's pretty much right. I mean, how, for instance, these models are interpreting these documents, right? So as you can see, right, I mean, these models are actually doing a pretty good job, and it's very easy to run a model like Flash on hardware that you own. In fact, you can even run it on a small NVIDIA GPU if you kind of quantize it right, right? So it's definitely possible, but of course, like how we saw, it's very important to kind of make sure that you first figure out what is the hardware your company can afford, what kind of concurrency you need, what kind of tokens per second you need, right, and what kind of models you want to be able to run. Should you be running multiple models at the same time? Right, all this dictates the kind of hardware that you need to kind of choose, right? Of course, if you are in a particular country and then you want to kind of only use models from that country, I'm sure many cloud providers already support those kind of operations, and then cloud providers will give you a contract or an agreement or terms of service where they promise you not to use your data in their training, right? So that's how Azure works. That's how Bedrock, AWS Bedrock works. So you do have a lot of options there, right? But we live in very interesting times where if you're only looking for cheap models, I want to run very cheap models because I have a lot of data to process. But then again, hey, I don't want to send my data to, let's say, to China. Then you have the option of taking the model and running it in your own premise, or in your own hardware. But you also have the choice of saying that, hey, I will use a Chinese model, but I will go with the provider who runs the Chinese model, let's say Azure Foundry or some other data center that is hosting that model for you. There are multiple ways in which you can, you can connect. For instance, if you go to LLMs here, you can click on LLM profile, and like I mentioned, there's so many different, providers that we support, and then you can use the model of your choice, and then we have models today that provide incredible value, right? So that's pretty much what I wanted to walk you folks through, and over to you, Mashli.
All right. Thank you so much, Shuveb, for walking us through that, right from the hardware options and how to choose it, and all the way to how it gets implemented. Let me just share my screen. So, folks, we'll be moving on into the Q&A from this point onwards. So you can start dropping your questions in the Q&A tab, and Shuveb should be able to answer them for you. We'll just wait for a couple of minutes so that everybody can start asking questions.
Yeah, there's one question here. It says we run a self-hosted LLM for extracting data from patient intake forms and clinical notes. We started with a smaller open source model to keep GPU costs down, but we are seeing more extraction errors on complex forms with dense clinical terminology. Is this a sizing problem, or could it be something else? Honestly, this is probably a sizing problem, right? So we have seen this pretty often, where, for instance, right, I mean, customers choose a very small model and they also heavily quantize it, right? And then what happens is that, they end up kind of making the model very weak, right? So as and when jargon increases, as and when complexity of the input documents increase, the model is going to struggle. More than struggle, we have seen a lot of hallucinations that happen. So one has to be like super careful, right? So it's a good idea to make sure that hey, you test the model by creating a golden set, right? So the idea is that you create a set of documents. You have a set of documents where you make sure that it covers or the set of documents is a kind of a representative sample of the kind of complexity that you will see in production, right? And then you choose a model and you run it against you run the structuring or whatever you need to do against that model, and make sure that unfortunately you'll have to sometimes manually verify, or you can use a larger model to do the verification, right? But sometimes I do feel that golden sets need to be manually curated, right? Of course, with help from AI you can always do that, right? So that becomes super important. So the idea is to have a golden set, have manually verified data, run it against the model of your choice, and then make sure that the performance that you need is there. If you see hallucinations, if you see wrong answers, then it just means that that model isn't capable enough. Unfortunately, you have to move up and get a better model, right?
We have a question in chat, Shuveb.
Ah, okay, how do you find the sweet spot between training your LLM for your use case versus giving up and trying out a higher model? Actually, this is a great question. And I also see that the industry is actually moving towards this more and more, right? But this does require a little bit of expertise in-house. That is the only drawback. So there are things like, hey, basically fine tuning. And if you take, for instance, the Quen models, right? One of the great thing about Quen models is how how elaborately they are documented, right? They're documented very, very elaborately. And you also have a lot of information on how to fine tune them and things like that. Luckily, right? I mean, you don't need a lot of samples to fine tune. Let's say you need around 2000 or so samples to fine tune, right? So what you do is that you take a smaller model, and then but you need to have hand curated set of questions and answers. And then, of course, you need to split them into a training and a testing part. And then you use LoRa, CLoRa. There are various techniques to fine tune these models. And we have seen that when you do that, even very small models can have amazingly good performance, right? But then again, the fine tuning for the fine tuning data, you do have to make sure that the data itself comes from a representative sample of your what you will see in the future, right? That's very important. So I hope that answers the question. If you don't have the expertise, the data, the time to fine tune your own model, very, very unfortunately, you'll have to go for a bigger intelligence, which also means that you can't run it. The larger the model, it's very becomes more and more difficult to run it in house, right? So yeah, these are some kind of compromises that you will have to unfortunately take care of it. Hope I answered the question.
There is a question in the Q&A tab. Sure, there's another one.
Sure. Can you throw some light on additional considerations when it comes to PHI data and HIPAA? We are on Azure, and of course, we wanted to fence our data, more concerned about audit compliance, right? So, yeah, I mean, see, there are a couple of ways in which people handle, PII data today. One is what we call as a replacement. The other one is what we call as tokenization, right? There are many solutions there, including solutions available on Azure, right? Unfortunately, right, I mean, the open source solutions that are available are not that great. So you might want to look at solutions like Protecto that you can run in-house, right? But if you trust Azure, right, you and and you have a contract with them, or you have terms of service that works for you, right? And you're able to convince your auditors, then you can use Azure directly. So, and you can within Azure, you can kind of split it into two. For instance, Azure themselves have a PII, PHI detector remover, right? And then there's a model service provider. Before you send the data to them, you can use Azure's own service, right? You can do that. Now, there's two ways in which people generally deal with PII, PHI. One is called replacement or masking. So what you do is that you just mask it with XXYY, whatever. But the problem is that sometimes, right, it might change the meaning of what is required, or you may actually need to extract something, right? So another way to do this is what is called as tokenization. So what happens is that the PHI PAI is replaced with tokens, and once the data is processed and comes back, the tokens are replaced again with the original data, right? So there's a couple of ways in which you can do that, right? Now, very, very unfortunately, when your security team, or the compliance team refuses to send data to a cloud provider, then your options become very, very limited. Unfortunately, the open source versions of the PHI PAI masking, and they're very, very limited, very, very unfortunately. Yeah. Otherwise you'll have to kind of roll out your own solution, unfortunately.
All right. Any other question, folks?
Awesome. Looks good.
All right, then. So thank you so much, Shuveb, for this session. And for everybody who's joined here, in case you want to explore Unstruct better and see how this sits with your particular business use case, you can always sign up for a free personalized demo where one of our experts will be able to sit with you, understand your needs, and see how you can take this forward. I've dropped all the relevant links in chat, and I also request you to leave your feedback on your way out. So thank you, Shoaib, once again for joining and giving us this presentation. It was really nice. And thank you, everybody. I'll be sending you the recording and see you in our upcoming events. Have a
Thank
great
you so much. Thank you so much, Mashi. Thank you so much, folks. Bye.